Just to set the scene, as you heard, I am sitting in South Africa. I am VPN'd into our data center in Naples, Florida. And what you see over here is my on-demand data center server that's running within our data center, the user interface part. We do have customers that prefer using a command line interface, so that's fully available. So the either can use the user interface or the command line interface. And then I'll also be using our MOAB scheduler, HPC scheduler, which is also, I also have a server running in our data center. So let me go ahead and log in here. So what you'll first notice is, as I call it, as a landing page. So first you'll notice there's multiple clusters over here. And these small little icons shows all the different service providers. So the top one over there is Google, which is also running in the United States. This is Azure, Virginia, United States. This cluster is with Amazon. It's running in Canada. And then I've got these two clusters over here from OCI, one in Frankfurt, Europe, and another one in Ashburn, United States. So it just shows, sitting in South Africa, I'm able to manage all my different clusters with different providers all over the world, right? So you're not restricted to provider, first of all. So you can have, we do have customers that use multiple providers in one organization, and also you're not restricted to clusters. So you can have multiple clusters and extend that further, where you could have clusters that are built differently, meaning different amount of nodes, different amount of types of VMs, and so forth. Now I'm going to drill down into one of these guys over here just to quickly show around, and then we'll kick off some workload, which we will run from on-premise bursting into the cloud. So what we see over here is a quick dashboard of currently what's happening. If we look under my queue, now this is a workload queue, a job queue within on-demand data center. You'll notice currently there's nothing in my queue. All workload I ran yesterday, all completed. And if you look at my clusters nodes, they both are down. So it's a small cluster. It's got 2 nodes. Each node has got 4 cores. And now that's the important part, is this cluster head node is up 24/7, but the compute nodes are actually down. So that's where one of the huge cost savings comes in, around about 50 to 70% cost saving by having your nodes down while there's no workload. So it's waiting for workload to come in. As my workload comes in, we will start these up, run that workload, and then automatically take them down again. And without going into too much detail, just regarding the nodes that are actually down, we use something called bursting. So there's different options. Minimum means if you, for example, have 10 nodes, 5 jobs, and you've got one node that will actually run all 5 of those jobs. We'll only start up one node and run them one after another. So we'll run them sequentially. That's even a further cost saving if you run the minimum option. Maximum means getting things done a bit quicker, meaning same scenario, 10 nodes, 5 jobs. If we have 5 nodes that will take care of all 5 of my jobs at the same time, that's what we will start up, meaning we're going to run that workload simultaneously. So that is getting things done quicker. And then we've got this option called all, which just means whatever is in the queue, irrespective of what's in the queue and irrespective of what's in my cluster, we will start up everything and get it done as quick as possible. All right, so from here, I'll jump into my MOAB scheduler. So over here, you'll notice this is a different user interface. You'll notice it's called MOAB Viewpoint. So it's our MOAB HPC scheduler, very well known, well used in the market. And this is the user interface part of it. Again, a lot of people use the command line interface, and it's fully available. Over here, we can see my current workload. Currently, everything completed, so you can manage and monitor your workload. And then I'll jump into my nodes option over here. Now, that is, again, what is available on-premise. Now, first of all, keep in mind, the on-demand data center side is part of bursting into the cloud. And my MOAB scheduler is the guy looking after my on-premise data centers. So over here, we'll see at the top, my on-premise node has got 16 cores. And And then all these ones listed over here on the left-hand side is what I've just shown you in my on-demand data center side, that it can actually see these nodes in the cloud. Even though they're down, they show as idle, meaning they're available. And my HPC scheduler, my MOAB scheduler, can actually allocate workload against that.
Mhm.
All right, so then I'm going to go into my templates. Now, what this is when we do the installation of MOAB, we come out with some standard default templates that are available, and then obviously you can add more. Now, this is where you would, on a command line interface, you can actually do that using the user interface from Viewpoint. So I'll just briefly show you the one that I'll run so that you understand what's going to happen. So this is this one where I call it Cloud Bursting Simulation All. I'm actually going to go in and just modify this one just to show you, without going in detail. I mean, there's a lot of technical details around this in the sense of how you can actually, configure this. Same thing as what you would do using a command line interface. Now,
Practically, you guys give a lot of flexibility.
Sorry, say again, Sam.
Oh, you guys essentially give a lot of flexibility in allowing people to have downtime to essentially lower costs and such.
Correct. Yeah. So the whole, you'll see as we run this, the whole purpose of this and the big, I want to call it the big feature or benefits is on premise, people have hardware, right? Certain VMs, GPUs, bare metals, whatever they need. Now, there may be, let's say, 100 researchers running workloads. Now, one or two of them may be using everything that's available, right? And some of these scientific applications can run for quite some time, sometimes hours, sometimes days. Now you've got 98 of your researchers that are waiting until that hardware becomes available, right? So they have to wait until whoever is using it, that completes, and then they can actually start running their workloads. Now, this is where people talk about a hybrid environment, meaning you run some workload on-premise, so you're full on-premise, and then to assist the others in also getting their workload done, we burst that workload into the cloud, so they don't have to wait. Now, that's one way of doing it, where we let our scheduler, being a intelligent scheduler, to kind of manage that, where it allocates hardware on-premise first, and then it looks at in the cloud. Or you can be very specific about it to say, well, I don't want you to run on-premise. I want you to run in the cloud. There's maybe a specific GPU in the cloud that you don't have as hardware on-premise. So you don't have to go and buy that. You can have access to that in the cloud, where you can use that. We spin it up for you, you use it, and then when you're done, we take it down again. Now, GPUs being very expensive, that's a very good way of doing it, because you don't have to buy it, first of all, so you don't have to put up upfront money for that, and you only use it when required. So you only bring it up, take it down, and then it's done. So it's all about assisting, especially in the HPC world, people to manage that workloads. Now, looking at this script over here, as I mentioned, is going to simulate some workload. It's small over here, but what it says at the top, I'm going to run 4 jobs. Each job requires 4 cores, so that's 16 cores. So that's going to fill up my on-premise environment, all my on-premise hardware. Then I've got different sets of user workloads also being submitted. Now, this is where I've allocated these different workloads from the users to each one of those clusters in the cloud. For example, that's to my Google cluster, my OCI Ashburn cluster, my OCI Frankfurt cluster, my Amazon, that's actually Azure, which is in Virginia. And then I've got my Amazon cluster in Canada, right? So that's what actually this is going to do. All right, so let's kick this off. So I'm just say there's a process we follow here to say, well, okay, I want to run some workload, create a job, and then it gives you access to the different templates that's actually been set up over here. So this is the one that we're going to run. So I'm going to go ahead and kick this off. Now, again, there's a lot of additional features within this that without, let me go ahead and create this so long, without, you could actually, as an administrator, can you give access to your end users so that they have to fill in some details, right? So you can set this form, this template up to say, well, you have to tell me what's the job name. You have to tell me how many cores you need. You have to tell me how many nodes, how many memory, or you can do it as I did it over here. There's no option. So that I already preset that. So that actually gets allocated. So this is going to now kick off my workload. This script actually kicks off all these different sets of workloads. So the 4 on-premise, and then between those different user jobs, about 26 different jobs is actually going to kick off. Now, if we look back at my viewpoint environment over here, now you'll notice before there was nothing in here. Now we've got them listed. Currently, they're showing as blocked. Now, that is part of the process that our scheduler takes. So the workload comes in. Now my scheduler is busy going through what is available on premise, where can I allocate all these different workloads that's actually been coming in. Now you'll see they're busy changing now into an active state. These bottom ones that says CentOS, they are the ones that's using my on-premise resources, and all these others that says user 1, 2, and 3, that's the different sets of users. And as my scheduler allocates these, you'll see that they change into an active state. So now it's being allocated into the cloud, so those people don't have to wait. Right, so let's jump back to my on-one data center side. So before I was, waiting for, there was nothing in the queue. So while we were watching, before there was 0 in my queue, now I've got 8 jobs in this queue on this specific cluster, which is an Ashburn OCI, and it will remain queued because remember they're actually down. So now we have to start those nodes up. So now you can see before they were down, now we're busy deploying them. So that's the full automation part of it as well. So we configure these clusters, switch on bursting, so they sit and wait for workload to come in. So as workload comes in, out of my 8 jobs, each one requires 1 core, 1 node. And between these 2 nodes, there's 8 cores available. So we'll start at both of them to take care of all of that workload. And it takes around about 3 minutes for these nodes, and that's very a common time between the service providers to start them up. And as soon as they're up, this is the process we follow here on the left-hand side. So they would be down first, which it was. Workload comes in. Now we're busy deploying them because we need to take care of that workload. As soon as they are deployed and available in the cloud, in that data center, in OCI, they become available, and then they become busy because they're allocated against that workload. So then they'll show busy and my workload runs. And depending on how long your workload runs, 5 minutes, hour, days, as soon as that workload is done, it goes back into available state. And if there's no more workload, we've got something within our cluster configurations called idle purge, which means how long should I keep these nodes available after we've deployed them? So mine is set to 2 minutes. After 2 minutes, no more workload. Then we move them back into an offline state, and then we start destroying them again. Fully automated, so you don't have to worry about managing that cloud resources, and people's workload actually gets taken care of. An end user sitting, submitting workload, they don't care about all of this, boys. They just want their workload, their jobs to run, and because they're busy doing testing scientific applications and so forth. And within the on-one data center environment, I can jump between all of these different clusters, right? So currently I'm at Ashburn, so let me go to Canada. So I'm jumping between these different data centers, between the different service providers. Now you'll see we're in Amazon within Canada, and I can see that this one is also deploying. Some workload has been sent to that. This one has got 4 jobs. So can I jump all over the world from where I'm sitting and managing all of these different environments. So it kind of just shows the capability of assisting people in running their workloads. And I'm not going to go into too much detail in the processes that we follow, but we have 4 steps. So I'll just show those. On the left-hand side, you'll see credentials. Now that means if you've got a credential with a specific provider. So it's a question of selecting a plus sign, and you can select any provider that you need to use, or whichever one you choose, right? So let's say it's Oracle, and it's a question of uploading that credential file. Now, the credential is something that allows you to deploy resources in the cloud, right? You've got a contract with a provider, or you can do it through us. We've also have our own, we call it a cloud mart. So we've got agreements with all the providers, and you can do it through us without having that agreement with a provider. The next step is actually, we call it a stack build. Now that's more technical in the sense of what we do in preparation for a cluster deploy. So with this step, we actually create an image so that contains the application, right? So each customer's got a different application. There's things like Foam and Star CCM Plus and Open API and so forth. Now, this is where we include that application on this image that we create, and it gets saved within the provider. And as a final step, in the cluster manager itself, this is where we configure our cluster. So we use that image that we created. That means that application will become available within your cluster's head node and compute nodes. So now you can run your application, which is on-premise, in the cloud on that cluster, because that application is installed on that cluster's head node and compute nodes, because we've done that image build. And then, these are a lot of technical details in the sense of each provider's got different things and require. But I think one point I will show is you'll see there's a figure over here. While configuring this cluster is currently 0. So you have to obviously choose your image that you created in the previous step. You have to use your credential, right? So that you're allowed to do this. And then the head node, you have to choose a size. Now you can see over here, there's different types, VMs, there's some bare metal devices, there's some GPUs in here. That's with OCI. Each provider has got a little bit different names they make use of. And we don't list all of them. You can imagine they've got thousands. And we only list the ones based on what your credential allows you, the commonly used ones, and we can change these based on what is required. Now, for the head node, typically that doesn't have to be big because it's something that just manages the cluster. So that sits over there, and now I'll choose a region, meaning a data center, right? So let me choose London, for example. You'll see that figure is now changing because of that head node size, 26 cents per hour.
Out of curiosity, sorry to interrupt. Out of curiosity, if you change the regions, does that also affect price in any way? For example, is it like cheaper? Yeah.
Right. So you're right. So and it depends again from provider to provider. They sometimes have different pricing per region or per data center for obvious reasons. I mean, for whatever they choose, that should be. So I could, and in this case, these ones are all the same. In some cases, they would change. So they may have a different price for that shape in Frankfurt compared to London, for example. So that could change. Yes, absolutely. Yeah. And also keep in mind, this is an estimated price. We know some customers have discounts with the providers, but this just gives you a good idea. If you deploy this cluster, that's what you're going to pay per hour. As we got so far, we've gone here. Now, without going through all these other details, at the bottom, this is where we configure our worker nodes, right? That's attached to this head node. So I'm going to say I want, let's say, that VM, and I want maybe, let's say, 5 of those. Now you'll see that jumps up a little bit based on that type of VM. 156 per hour. I can add to that, so we can make it a heterogeneous cluster, meaning different types. And if let's say I choose GPU A10 from NVIDIA, those are these more expensive type of shapes. So let's say I want 3 of that. Now you'll see now it jumps up to 25. So if I were to deploy this cluster as it is with a head node, these 2 nodes, that's what I'm going to pay per hour. So that gives you an estimate just to help you just understand. You're going to deploy this is what you're going to pay. But this is where we talk about the bursting, which I mentioned earlier. If I switch on any one of these bursting options, we're going to take down these nodes and only start them up while workload comes in, right? So in that case, I take that one down and make that one 0 because it's all down. That's all you're paying for this cluster because you are making use of a bursting option. So that's why this is very important in that sense. All right, so let me just quickly go back to my environment that was running here. It's possible that some of my jobs are completed. So then you can see that, as the workload completes, they go, now you'll see we're actually busy running my workload. So my nodes have actually now started up. So they're busy, they're available. And if I look at my queue, you'll see that all my workload is actually now being taken care of. Mm-hmm. And as this workload completes, as I mentioned, it will go into available state. And as I mentioned, within our cluster configurations, I can set how long should I keep these available. So while we were talking, it just finished. Now it's available. So now it will wait for 2 minutes. Then we've got something called the burst cycle. So then we start taking these nodes into an offline state. And then we start destroying them, and they're down, and then it waits for the next set of workload to come in. Mm-hmm. So I'll finish at that. There's a lot of other details around this, capabilities, features available, especially in our on-demand data center, as well as our MOAB suite that's got a lot of other features, that's accounting and reporting and so forth.
Mm-hmm. Thank you, Rian. Thank you for that.
Yeah.
Can you stop sharing your screen? And Sue, can you show Sam the diagram that describes all of this?
Oh, I just had a quick question for Rian first, actually.
Yes. Sure.
When you were talking about the nodes and after they're finished, how come you guys, so I understand that they go offline, but I'm curious, how come you guys destroy them? Is that just a normal part of the process, or?
It is important because you would have seen there, I was talking about offline. So offline means they're not terminated completely. And one of the main reasons for offline, first of all, is let's say I move them into an offline state and suddenly more workload comes in. It's much easier for us to move them back into available state because they're still available, right? So they're still not completely down. When we talk about destroying, that they actually get terminated completely. They don't exist at all.
Mm-hmm. And we don't have to pay for them.
Yes.
Got it. Okay.
That's the main thing, because the providers, some of the providers actually have a feature where you say you can just stop it, right? You don't terminate it, you just stop it. But then you still pay for example, storage and other areas as well. Terminating, you get rid of it completely.
Got it. I wasn't sure about the specific nuances, but yeah, I got it now. Okay, thank you.
Good.
Yeah, the big point is that we save 50 to 70% of public cloud costs compared to a persistent data center in the cloud by starting them up and shutting them down.
Yeah. No point in paying for servers if you're not using them in the middle of the night.
Right, exactly, Sam. Sue, you want to take this?
Sure. So on this diagram here, we are showing our technical approach of what goes on behind the scenes with integrating a customer's on-premises assets with those within the cloud service providers. So you'll see here on the left a user submitting a job to an on-premise system via the job scheduler, which in this case is MOAB. In that case, the job would run on-premise like any other job. However, it could burst out to the cloud when the on-premise systems fill up and there's no more capacity. It is set up to burst out to the cloud providers and then take capacity and use it from the cloud providers. So it will work that way, and that's called a hybrid cloud, bursting from on-premise to get those additional resources. And then it also works where the user will submit it directly to the cloud queue. So the job will go bypass the on-premise system and go directly to the cloud. In that case, they can choose any one of these cloud providers or all of them, should they want to. And they can switch between the cloud providers. So they can have workload running on Azure, AWS, OCI for HPC, OCI, Oracle Cloud Infrastructure, Alibaba in Asia and Europe. And also, Adaptive Computing has its own cloud offering called HPC Cloud Mart, where we offer customers the opportunity to use the cloud on a pay-as-you-go basis with everything included in an all-inclusive pricing model that makes it very easy for them to begin to use the cloud and either experiment or gradually maybe balance workloads between on-premise and cloud systems, or start to run workloads in the cloud gradually without any upfront expense or cost.
So Sam, this diagram shows exactly what Rian demonstrated
Yep.
for you live.
Yeah, that's exactly what I got. I do have one quick question. So you guys did mention this, but it is also a part of your services. So from what I understand, usually you need to have an agreement with, Azure, Alibaba, or Amazon in advance of using their services. Is that correct?
Yes,
That's
it is.
correct.
But you guys offer practically you guys say, hey, if you don't have one, you can just use ours as pay as you go.
Correct.
Yes.
Okay,
Correct.
perfect. Yep, just figured. Wanted to make sure because I wasn't sure if others did pay as you go as well, or just specifically you guys. But that's actually a good differentiator.
Yeah.
Ours is pay as you go. The others, you have to make a commitment up front to get any discount at all. So we already have agreements with all the cloud providers that we pay the cloud provider and then the customer pays us.
Yeah, exactly.
Okay. And then Rian, talked a little bit about how we configure to deploy to the cloud. I'll let him talk to that a little bit. I'm not sure that we need that much detail.
Yeah, I don't think we need that, Sue.
No, you have to keep in mind we have to keep things very much on the surface.
Right.
So
it'd be something like this diagram only live.
practically, yeah.
Right.
It'd be an animation of this diagram.
Where the user would submit the workload to the
Right.
on-premise. Their
Yeah.
on-premise would fill up.
And then
And
it bursts to the cloud. And
then it would go out to the cloud and get more infrastructure out in the cloud providers.
so, Sam, that's what I think after, spending some time chewing on it, is that if this diagram were just automated,
Mhm.
or animated, I should say, I think that's probably what we're looking for.
Yeah, so something like this would probably be in the second half of the video when we're talking about your services, right? We would start off probably by saying, oh, you can have the flexibility of, everything
Okay.
essentially, right? And then we would go into all of it. We would be like, oh yeah, you can still use your on-premises, but when that gets filled up, then you could use our service, so on and so forth.
Yep. I love it. So what's the next step, Sam?
Perfect. So we'll just need two things. One will be this recording afterwards, and then the other thing. Hold on, I just need to check.
You need the diagram, Sue.
Okay.
The recording and the diagram.
Give me a quick second. I'm just checking. Oh yeah. So we need a script questionnaire, the practically this video, as well as feel free to send over that diagram. You can also save it for the storyboard stage, and then we just need the invoice paid. And then once we have these three, we'll be good to go.
And that's that 50% invoice, right?
Correct.
And then also, if you need it, when you go into the animation phase, I can pull out these individual pieces as vector graphics.
Odds are we'll probably recreate this.
Oh, okay. Okay.
Yeah, so we can animate it as well as, stylize it a bit.
Okay, sure.
All right.
Good.
So, Rian, thank you very much. Sue, thank you as always. And we'll get things going, Sam.
Absolutely. Did you guys need me to resend anything over? Or did you guys still have everything?
No,
I
we
think
have
so.
everything.
Perfect. Yeah, if you guys need anything else, you guys know where to find me.
Thanks, Sam.
Thank
Excellent.
you.
Pleasure meeting
Hey,
you. Rian.
Rian, Sue, can you hang on for a minute afterwards?
Sure.
Have a great day, guys.
Yep.
You too.
Thanks, Sam. I say this, or I said this yesterday on the Caterpillar call, but I'm going to go back to